equation, but these ones have a couple more steps. I'm going to skip A just because I'm going to try to like skip 1 or 2 here so we don't have to do every single one. But let's start with example 5, letter B. Okay? Now, this one has more steps than yesterday, but I think as we go through the more steps, you'll remember the logarithm law that we did yesterday. So we're solving this for x. Now, treat it just like a regular equation. What would you do first to solve this equation? Plus 3. That's right. You cannot use the logarithm to solve this until we get rid of the 3 and the 4. So we'll have 4 times 2 to the x equals 20. And then again, because that 4 is in front, I can't use the logarithm until I divide it away. Right? That's the main thing to remember here is you cannot get rid of the exponent until you delete the other numbers. So we will have 2 to the x equals 5. Now that 2 to the x equals 5 looks just like example 4 that is right above this on your paper. And do you remember yesterday, I told you a little story. It was a great story. The best story you've ever heard, I bet. Come on, Brandon.
I was laughing.
Oh, okay.
I was laughing. I'm trying to think back of the story.
The story was we were playing basketball in the woods, right?
Oh, yeah.
And the x is like your basketball. That stuff you have to throw a log at it to get the x out of the exponent. So you're going to take the log of both sides here. I'm just going to squeeze log in. We have log of 2 to the x and log of 5. Now what does the logarithm law we learned yesterday say about this exponent? Where does it go? It comes down in front of the log. So what you really have here is x times log of 2 equals log of 5. And we're going to now just divide by log of 2, and you are all set to put that into your calculator. Right? I didn't even pull up the calculator yet. I can work on that while you're getting yours, just in case we need it. But you should get a decimal. And now in this unit, we are going to be rounding to 3 decimal places unless it tells you otherwise. What you guys get as an answer? 2.322. Does anyone need to see typing that in? Because I got a wrong answer. Good on that one? Okay. So that problem just shows we can still solve them, but sometimes there's extra steps involved. Let's look at the next one and see. I don't remember if that was one I was going to do or not. Let's look at C. Oh yeah, I do want to look at C real quick. Just to review from yesterday and then move on. I have 17 times 5 to the x over 3 power equals 4. So let's start with dividing by 17. Now does 4 over 17 simplify to a nice? No. So you have 2 options here. You can either figure out if there's a nice, like a decimal that works. I don't know what the decimal for 4 over 17 is. Let's see. Oh, it's really long and yucky. Do you think we should round that decimal or should we leave it as a fraction? I think we should leave it too. So let's leave this as 4 over 17. Okay? Because when you type it in with the log, you'll just put it in the parentheses. It won't matter that you have a fraction. Well, now I have 5 to an exponent by itself. So now to move that exponent, I'm going to take the log of both sides. And remember yesterday I said I'm going to just kind of skip the writing the log part and skip right to pulling the exponent in front, just to save some time. So I have x over 3 times the log of 5 equals the log of 4 over 17. Now for these ones, the next thing I would do is I would get rid of the log. My preference is before you deal with the stuff that was the exponent, I would just divide by log of 5. That's just how I like to do it because I think it gives you like a nice fraction with logs and then you can do the other stuff. Oh, that's right. That's how I feel. X over 3 equals log of 4 over 17 divided by log of 5. And how do you finish this one up? Times 3. That's okay. You're allowed to get a negative for the x. Yeah. Good. So you take log of 4 over 17 divided by log of 5. You hit enter. And then you hit times 3, and I also have a negative number. Let's see if we got the same negative number. had? Negative 2.697? That's just the x. So, like your exponent here is going to be negative. You can have negative exponents.
So like, there's no negative numbers in the rows and cross, so it's become negative.
It's just whatever the value of the logarithm is. I think it's because, I would say probably because there's a fractional exponent. That it. Yeah. I know it's a little vague, but it's from the exponent with the fraction. Alright, now, we didn't talk about natural log yesterday. I want to ask you real quick before we move on. When we take the log of both sides here, we're just doing log. What kind of logarithm is that? The common log. Now, if we have any number, so if it's just a number to a power, you're going to use the common log. If you look at example 6, I now have e to the x equals 14. So technically, you're allowed to use the common log, but I would use here the natural log, right? Because we know that the base of the natural log is what? E, right? So like natural log of e. Now, we're going to use this fact in a minute here, but do you remember what the natural log of e equals? No. It's okay if you don't. Remember, there's a little invisible base of e down here, right? Right? Yeah, so if you think of it, e to the first power gives you e. So natural log of e equals 1. That is going to be something that you should remember. It's going to save you a little bit of typing in your calculator so you won't get carpal tunnel when you're older. You guys know what carpal tunnel is? Yeah. Carpals are like the little bones in your wrist. It's like it's like little bones in your wrists and stuff, and they get aggravated or different things. Yeah. So if you see like adults or like people who sleep with like wrist braces on at night, it's painful. You have to have surgery. Yeah. All right. So I have e to the x equals 14. Now this one, I already have base of e. So I'm going to go ahead and throw my natural log at both sides here. I'm going to write out the whole way for this one, and then we'll shorten it up for the next one. The same logarithm law applies for the natural log. So that x still pops out in front. So it's x times the natural log of e equals the natural log of 14. Now here's where it saves you some time. We just said the natural log of e equals 1. So really, this is just a 1 right here. So what you really have is that x equals the natural log of 14. Save yourself some pencil lead too. Don't divide by the natural log of e because you're just dividing by 1 and you're not going to change the value. So you can skip right to the part of typing natural log of 14 into your calculator. What do you get when you type the natural log of 14 into your calculator? 2.693. Sorry. That is what I had on my paper, and I reversed the two numbers. Okay. Good. Now the next one here, let's see, should we do B or E? Let's do B. 2 times e to the x plus 1 equals 26. Where do you start here? Subtract the 1. Okay. So we'll have 2 times e to the x equals 26. And I can't do the log until I get rid of the 2, which I'm going to do by dividing by 2. Right? So you have e to the x equals 13. Now you take the logarithm, and I'm going to skip that step and bring the exponent right down in front of the natural log of e. But again, what does the natural log of e equal? 1. So I'm just going to kind of ignore it. It's like you look at my answer sheet, I just kind of put a little line through it. I'm not like crossing it off, but I can kind of ignore it because it equals 1. So all you have to do now is type x equals the natural log of 13 into your calculator. And you will get the value of x. Yeah, 2.565. Very good. We good so far? All right. Let's skip to the next example. Right? I'm trying to save us a little time. And like, for the purposes of learning, it's good to do a lot of examples because Believe it or not, by Monday you'll be like, I kind of forget how to do that. But it also is kind of annoying to have to do a bunch. He's parking in the no parking zone. He is. You know, actually, so that my car is one of those out there. And last year they used to come and ticket and tow people. Like I saw those tow blue one. My car is the first red one. Yeah.
The red one comes.
Yeah. She just.
So you guys park next to each other?
Yeah. I park there because. Oh, I don't park there during track suits, but I park there the rest of the year because it's like. And I get here at like 6:15, so I can usually.
You could have a car.
You could. But we're trying to be nice and not block the mailbox.
You can watch. That blocks.
Yeah. Yeah, that's just too. I mean, it's like a good 5-minute walk from here to the other parking lot, which isn't horrible, but like some days you just don't want to walk.
Like a parking spot.
Yeah. Yeah, I could, but like, especially like during cross country when I have to get to Dempsey so fast, it's easier just to like get out. Save a few minutes. All right, let's talk about example 7. When I look at number 7, 7a, we have 5 to the x plus 1. What would you say we should do first here in this problem? Throw a log at it. When I throw a log at it, this whole exponent, x plus 1, is going to come down. My suggestion to you is you put x plus 1 in parentheses. Okay? It's the whole exponent x plus 1 times the log of 5 equals the log of 82. So when you bring that whole exponent down, you should have it in parentheses. Now before we deal with x plus 1, you have to think about your order of operations. It's the whole quantity x plus 1 times the log of 5. So you are not allowed to subtract the 1 yet. Right? You can't get at what's in that parentheses until you move the log. So we're going to divide by log of 5 next. Okay. It's a lot of writing, and I promise you there'll be more writing next week. It just gets worse. So we have x plus 1 equals log of 82 over the log of 5. Okay. And then your last step is now finally you can move that 1. So you would subtract 1 here. So when you put this in your calculator, you're going to type in log of 82 divided by log of 5. I would then hit enter and then subtract 1 from it. Okay. You're going to do that on your calculator. Make sure that you are very careful and that you practice. And you're going to tell me what you got. Bless you.
I did it.
Yes. That's what I got. Good. Questions so far? Pretty simple? Yes, ma'am. If it's just a number, like 5, you use the common log. If it is an E, you use the natural log.
What? Yeah.
Okay. All right, let's look at, let's do B. All right, where do you start here? Not yet. Divide by 4. You cannot throw a log at it until that number stuff that's outside. You just have to have e to the power by itself. So you'll have e to the x plus 3 equals 9. Good. Now you can throw a log at it. We're going to throw what kind of log at it? The natural log. So again, you have x plus 3 in parentheses times the natural log of e. Equals the natural log of 9. Yes, natural log of e is 1. So I'm just going to kind of put a little line there because that's 1. I don't have to deal with it anymore because dividing by 1 doesn't change the value. So what would be your last step here? Subtract the 3. Does it equal 6? Is it a whole number?
Oh.
No, it's decimal.
I didn't get the log instead of
Yeah. The log part would help. So natural log of 9 minus 3. I think you should get a negative decimal here. I think it's negative 0.803.
Yeah.
Alright, do we have to double check this one? Natural log of 9, close your parentheses, minus 3. If you don't close your parentheses, then you'll get a different answer. Yeah, if you keep your parentheses open, it'll do the natural log of 6.
So like, I just put Oh, no, I thought logs.
Oh, yes. Yep. All right, next one here. We're almost done. This one just has to do goofier looking exponents. I want to double check. We have 2 times 3 to the 2x minus 5 equals 120. And you'll see why we have to do all this solving stuff when we get to the application problems next week. Where do you start? Divide by 2. All right, what's 120 divided by 2? 60. All right, so we have equals 60. Now, when you throw a log, what kind of log are you going to throw at it? Common log. When I throw this common log, the whole exponent of 2x minus 5, the quantity, comes down in front. Huh? Yeah, sorry, I forgot my 0. Yeah, I got you now. I was confused what you said. Yeah, you're good. All right, what is the next step you are going to take? Divide by the log, right? Ignore what's in the parentheses here and jump right to that. Okay. Well, it's a lot of writing, but you still have 2x minus 5 equals log of 60 over log of 3. Okay. What would you do next? Add 5. So we still have to add the 5, so I'm just going to kind of tack the 5 on the end. And then instead of rewriting this, then what do you have to do? Divide by 2. So then you're going to take that whole thing divided by 2. So you just need to be very careful when you write this and solve this.
Do I have her?
In the back. Noah and Zach. Especially since some of us had trouble today on our quiz. Okay, so let's be really careful typing this in. I want you to try it on your own, see if you get the right answer. I want you to actually type it in. You should get this, 4.363. I want you to check. If you don't, we'll go over it. But I want you to actually practice typing it in because that's probably the hardest part here.
Got it.
You did good. You got the same thing. No, just let it commit. That's fine. Yeah, because it just, yeah, you're okay.
Do it all at once.
I would make sure you do the times 3 in a different, or times 5. So division is separate. All right, anyone not get that? So here's what we're getting with this. Let's go back to that last column. I'm not going to read all those words, but this is a reminder of how we started the unit, talking about the bacteria in the swimming pool. I know, it comes full circle. So full circle. We can now, finally, for the 4th time looking at this problem, solve this exponential. Let's solve it, and then we'll be done for the day. We'll have, felt like we made our life complete. Where do I have to start in this problem? Divide by 1,500. All right, so you're going to divide by 1,500. Do you either remember or calculate for me? What is 3 million divided by 1,500? 2,000. 2,000. Is it 2,000?
Yeah, you
All right, give me one. All right. So is it 2,000? Yes? Do we agree? Do we decide? 2,000 equals 2 to the t, right? All right. Let's finish this up. Let's take the log. What kind of log are you going to use? No, the common log. Common log of 2,000 equals t times the log of 2. You'll get t by itself by dividing by log of 2. And when you do that, when you take log of 2,000 divided by the log of 2, how long, what's the time? Remember, this is days. How many days until there were 3 million bacteria in the swimming pool?
Almost 11.
Almost 11, but what decimal? 966 days. Yes. So that's where we're heading with this unit. We're not just going to be solving basic exponentials like this. We're going to teach you some more fancy, complicated looking ones. But we'll do after. So there's a little bit of practice on the back. Give me a few minutes if you attempted some of those problems. If you want, you can skip down to number 3. So number 1 and 2 are just review what your quiz was on today. Number 3 is where we start to get some of the new stuff. So if you want to try some of those before we finish, Monday we will do a work day.